Let's do part B. The machine is sold when its value is less than 550. So this is a nice one because it's always going to be there on these compound interest things. They say, how long does it take for the value to be bigger than? You know, they like to say that. How many years is it going to take for the value to be bigger than? Or how many years is it going to take for the value to now be smaller than? Because here we know that the value is depreciating, okay? Because if we see here, what was the original price? 3K. Look at the price after 4 years. It's now 1.5. We have lost money here. Okay, this thing is losing value. So here they're saying, calculate how long it's going to take for the value to be less than 550. So when they say for the value to be less than 550, you are going to know how long it takes for the value to get to 550. Then we can use that answer to know which one to take. Okay, so let's go at part B. Okay, this was my part A. Now we're going to say part B. They're going to say how long, which is time. Okay, how long does it take? And that is going to be your N, right? That's going to be your N. So what did we have here? We always come back here. Don't ever forget this formula, okay? So here we'll say Tn is equal to A outside multiplying 1 plus R to the power of N. This is the compound interest formula. It's a GP, it's a type of a GP. So here we have it like this. We don't say N minus 1. Our power is not N minus 1. Please watch out when you do it. The power is N. Now here we have it. We know it was depreciating. We know everything. We know that what is the term? What is that Tn? What is the value we are getting to? 550. So we're going to put 550 here. Is going to be equal to, what is my A? 3,000. And it's going to multiply 1. And then what is my R? It will be 1 minus 0.15. And it is to the power of N, which is to the power of N. We don't know. So here we're going to have 550 is equal to 3,000. We can take 3,000 to the other side since it's just multiplying. So we'd have 550 over 3,000 is going to be equal to 1 minus 0.5, which is 0.85 to the power of N. So I'm going to say, what is 550 divided by 3,000? We'll get 0.18. I change it to a fraction. Remember, to change to a fraction, you say second function, then the balance which says A, B over C. And you get it as 11 over 60 is equal to 0.85 to the power of N. Now, what do I do here? I'm going to just, to find N, I have to introduce logarithms, okay? And the logarithms which I introduced, there are only 2 logarithms. Some logarithms are not there in the calculator. There are 2 which are there, which is ln and log base 10, okay? Log base 10, which is sometimes just write as log, or we can write it as log base 10. So ln is the natural one, okay? And then log base 10 is the common one. It's called the common logarithm. These 2, we have them in our calculator, we can get them. So let's introduce ln both sides. Ln of 11 over 60 is equal to ln of 0.85 to the power of N, because it is good at dropping down powers. So in here we have, from laws of indices, it says when you have 2 things dividing inside a log, they will subtract. Their logs will subtract. So it will be ln of 11 minus ln of 60 is equal to N multiplying ln of 0.85. All right, so here, so what do we then do here? We're going to take the ln 0.85 to the other side. So we have ln of 11 minus ln of 60 divided by ln of 0.85. Okay, what are we going to end up having? We're going to end up having N. So let's punch it. Say open bracket, ln 11 minus ln 60 close, divided by ln 0.85. Okay, so here we are getting the thing. And here when we punch, we're going to get 10.438 blah, blah, blah years, right? So 10.438 years, and this is equal to N. So what is that going to be? Remember that this thing is going down, and they said, how long does it take? This is a very important question because it comes even when you are increasing the value. Here, it so happened that this was a depreciation question, which is exactly like a compound interest. Okay, for depreciation, we treat it exactly the same way we treat a compound interest. They can say compound interest, you use these formulas. When they say depreciation, you use it, but remember that it's going down. Remember that. So in here, our thing is going down. And here we get 10.438 years. That is how long it takes to get to 550. But they want the value to be less than. So for it to be then less than, you can't say I'll round off. And since this is a 4, it's going to be 10 years. No, 10 years, the value will still be greater than the 650, because remember, the value is going down more and more with time. We want the value to be less than 550, okay? So what would we have? So we're going to say, all right, since this was 10.438 years, we are going to increase it so that it is now going to be less than 550, because if we drop it down to 10, remember, it needs 10.4 to just get to 550, okay? So and 10.4 is more than 10, right? So now we want it to be even less than 550, so we can't round back to 10. It'll be more than 10 years, right? And what is the next year which is more than 10? 11, okay? So we'll use 11 years. We'll always round up and we say, definitely, by the time you get to 11 years, we now know that your value will be less than 550, because in 10.438, it was now 550, okay? To get to less than, let's use 11 years. And that's what you do even when the value is increasing. You're going to say, okay, they say, how long does it take to get to 5,000? Or they say, how long does it get to get more than 5,000? For you, get for 5,000, and we know that for more than 5,000, we'll add one more year to that, okay? And you'd be done. All right, that's it. Goodbye for now.